Hey everybody. Well, we just finished section 6.2, which was on solving trigonometric equations. And we saw there was a direct relationship between solving a linear and quadratic equation from algebra and how to solve it in trigonometry. We also saw when we solve a trigonometric equation that we're finding the missing angle, theta or x. And we find that missing angle, we could either have our answer in degrees, dd, dms, or we could have it in radian measure. What's going to happen in section 6.3 is now we're going to look at some more complicated trigonometric equations we want to solve. And what's going to make these more complicated is the angle is not going to be just good old 1 theta or 1x. It may be a double angle, 2 theta, or it could be a half angle like x over 2. In that case, we have to talk about what methods do we apply to solve. Because when we solve a trigonometric equation, we don't want to know what the angle 2 theta is or what the angle x over 2 is. We just want to know what the simple angle is, theta or x. So if we go to our notes, we have 3 examples here. And if you look, all 3 have to do with maybe a double angle. So in the first example, we have 2 sine theta equals 2 cosine 2 theta. There it is, our double angle. In our second example, B, we have cosine 2 theta. There it is, our double angle. In our third example, we have sine 2x. Again, a double angle. Now, the problem is we're trying to solve for x, or theta. Well, we cannot just take that 2 away from that angle. Okay? That's connected. That is the angle. So our job is going to be, how do we make a double angle just become a simple angle x or theta? Well, think about what we learned in chapter 5. Double angles have identities, properties, rules that they equal. So the first method to deal with this kind of equation, an equation that has an angle that's not just singular, 1x or 1 theta, is to use one of your identities to substitute in. And just like when we had chapter 5, in this chapter, yes, you'll still have that list of all those double angles and half angles. So if we look here, our first thing is going to be to always see if we could substitute for the double angle. Now, the reason what makes cosine 2 theta so impossible to work with is because we don't have one identity equals and we have 3. And that's what you got to recall. In your notes from section 5.5, cosine 2 theta or 2x can equal 3 different identities. It can equal cosine squared theta minus sine squared theta. It can equal 2 cosine squared theta minus 1. Or it can equal 1 minus 2 sine squared theta. If we're about to do a substitution, replace this double angle with one of its identities, which shows the angles are all now theta, singular. It matters which one you pick. So we have to look at the other trig function in this equation. The other trig function in this equation is sine. So when we do our substitution and we replace this identity, we also want to replace with the same trig function sine. So out of our 3 choices, we would want to substitute for cosine 2 theta, 1 minus 2 sine squared theta. And that's what we're going to do. We're going to leave the left side alone. We're going to leave that 2. We're going to replace cosine 2 theta with what it's equivalent to. So we're going to put that in parentheses because it's going to be connected to the 2 by multiplication. Okay, so there's my substitution. What that does is if you look, this angle is singular theta, and this angle is singular theta. And that's our goal, to get it back to where we started last week. Now we'll just follow our algebra. We'll distribute. 2 times 1 is 2. 2 times negative 2 sine squared theta is negative 4 sine squared theta. Then you have to ask yourself, is this equation linear or quadratic? Well, it's got a square, so it's quadratic. Quadratic equations we normally like to set equal to 0 and factor. On this one, our sine squared is negative. Well, if you remember from algebra, you never want to factor with your square being negative. So I'm going to move both of these terms to the left side. So I'll add the 4 sine squared theta to the left, and I will subtract the 2. because in order to factor, all the terms have to be on the same side. Then I need to put these in the correct descending order. So this would go 4 sine squared theta. That's a positive 2 sine theta minus 2 equals 0. So remember, when we're going to do the factoring method to solve quadratics, we want our terms in descending order. Then, because this is factoring, we're going to go through the rules. The first rule of factoring is GCF. GCF means what do the terms have in common? We could divide them out. And they all have in common the constant 2. So I'll divide out the 2. I'll get 2 sine squared theta plus sine theta minus 1 equals 0. But we're not completely done factoring because we still have in here 1, 2, 3 terms, which is called the trinomial. So we know we can break that into 2 parentheses. When I factor trinomials, it's doing the method backwards FOIL. I know what FOIL stands for. FOIL stands for first, outers, inners, and last. So when we factor a trinomial, we start with the first term. What can multiply to 2 sine squared theta? That would be 2 times 1 is 2, and it would be sine theta times sine theta. That'll make sine squared theta. Then we go to the last. What can multiply to 1? Well, that's easy. It's only 1 and 1. Now we have to get the symbols. We want to subtract to get a positive 1. So if we want to subtract, the signs have to be different. If we want a positive 1, the positive has to go to the larger. Well, who's larger, outers or inners? Well, your outers are 2 sine theta. Your inners are 1 sine theta. So your outers are larger. That's where the positive goes. And there's your inners. And remember, you can always know if you factored correctly by multiplying that out. It should get you back to that trinomial. This 2 in front is no longer needed. All we do is pull out that 2 to make our trinomial easier to factor. We know when we factor a trinomial, a quadratic, we should get 2 linear equations. Well, now here's our 2 equations. So 2 sine theta minus 1 is 0. 1 sine theta plus 1 is 0. Now they're linear. We isolate, so we move over the 1. So 2 sine theta equals 1. We'll divide by 2. So we get sine theta equals a half. Over here, we'll just subtract 1. So sine theta is negative 1. So remember, the whole goal of solving a trigonometric equation is to isolate the trig function. Okay, we did that, but we're not done. In trig, I'm giving you the number. I want the angle. I'm doing an inverse. So we're going to rewrite this correctly. We're going to say theta is equal to, if I do the sine inverse of a half. Theta is equal if I do the sine inverse of negative 1. We don't need a calculator because we can look up a half on one of our triangles, and we can look up negative 1 on our unit circle. Okay, if these were numbers we couldn't look up, then we would do the inverse on our calculator. But again, we're always back to the beginning definitions. So to look up a half, by now, I would think you know that's off the 30, 60, 90 triangle. Here's the 30, the side opposite is 1, the hypotenuse is 2, the other side, the adjacent side, is square root of 3. The definition of sine from way back when is opposite over hypotenuse, or y over r, and there's the half. So we know the sine value would be a half at 30 degrees. But because that's positive, it could be in another quadrant, quadrant 2. So remember, this is called the reference angle if it's in quadrant 1. So to get the angle in quadrant 2, we do 180 minus this. So another solution here would be 150. Okay? Then we're going to do the sine value. Where is that negative 1? Well, negative 1 comes directly off our friend, the unit circle. So we know our coordinates, 1, 0, 0, 1, negative 1, 0, 0, negative 1. Okay, we all agree? I'm looking up sine. I want a sine value in negative 1. The y values are the sine values, and that's right here, and that's at 270 degrees. Then we'll go, after we're done solving, we'll make sure we have our answers written in the correct units. It says up in the homework here in the examples in the notes, give the answers between 0 and 360 degrees. So there we go. So all we did differently in this exercise is understand if you have a double angle, you can't have, to solve a trig equation, a double angle and a singular angle. If you can do a substitution, then you do it. All right, let's go to example B. It says cosine 2 theta plus cosine theta equals 0. So again, there's my double angle. The reason why I'm picking cosine 2 theta is because that identity from 5, has 3 choices. And it matters which choice you pick. So we look at the whole equation and we say, okay, we have a cosine function. That's in lowest terms. So when we do our substitution here, we need to keep this in terms of cosine also. So for this example, we would use the second. We would substitute in for cosine 2 theta, 2 cosine squared theta minus 1. And then bring down plus cosine theta equals 0. Okay, so you have to pay attention to that identity because it has 3 options. Remember, to solve a trig equation, you want everything to be terms of the same trig function. Then we would look and say, oh, that's quadratic. I got a square, so I need to make sure everything's written in the correct order. So the squared term should go first, then the cosine, and then at end, the constant -1. We're going to go through our rules of factoring because it was set equal to 0. Is there a GCF? No, there's not. They all do not have a 2 in common. They all do not have a cosine theta in common. So there's nothing to factor out. So this is the straight trinomial rule. I'll put my 2 parentheses. I'm just a creature of habit. Every time I factor a trinomial, it's doing FOIL, first, outer, inner, last. Okay? What can multiply to 2 cosine squared theta? Well, 2 is 2 times 1. Cosine squared is cosine theta times cosine theta. Then I go to the last. What can multiply to 1? Well, that's easy. 1 and 1. I want to subtract to make this positive 1 in the middle. Subtract means the signs have to be different. So to make a positive 1, I want the positive to go to who's bigger, the outers or the inners. The outers, again, are 2 times 1. This is 2 cosine theta. The inners are 1 cosine theta. So this is bigger, outers. So I'll put a positive there and a negative here. Now I no longer have a quadratic. I have 2 linear equations. So I set equal to 0. And then I solve. To get cosine theta alone, I'm going to add 1 and divide by 2. That's going to give me cosine theta equals 1/2. To solve for cosine here, I'm going to subtract 1. So cosine theta is -1. But we're not done. Remember, we're trying to solve for an angle. So the only way we get at an angle is do the inverse. So we're going to write theta is the cosine inverse of 1/2. Theta is the cosine inverse of -1. All right, we're going to look up cosines 1/2. Well, if we go to the 30 triangle, it doesn't work. Because if you do the definition of cosine, cosine is x over r, or adjacent over hypotenuse. And 30 degrees will not give you 1/2. So if it's not 30, I think we all by now know what the answer is going to be. It's got to be the 60. So if I change this to the 60 degrees, we know opposite to 60 is square root of 3. The hypotenuse in this triangle is always 2. That makes the adjacent side 1. So if I now do the cosine of 60 and I do x over r, or if I do adjacent over hypotenuse, I do get the 1/2. So theta would be 60 degrees. But cosine is not just positive in quadrant 1. Cosine is also positive in what quadrant? That's right, quadrant 4. All students take calculus. So that means I need an angle in quadrant 4. So remember, this guy that's 60 is our reference angle, that angle. So to get an angle in quadrant 4, you do 360 minus the reference angle. 360 minus 60 would give us 300. But we're not done. Now we got to look up the cosine inverse of -1. Well, we know the -1's coming off the unit circle. Where on the unit circle is the cosine value -1? Well, cosine again is letter x, and it's right here, and that's 180 degrees. And the direction said give the answers between 0 and 360, so we'll stay in degree mode. There are our solutions. It's not that bad, right? All right, let's try one more in the notes. This one says sine 2x equals cosine x. So again, there's your double angle. Your first means of dealing with this is to see if you can do a substitution. Now, this one's great because there's only one option. If you go to 5.5 and look at your double angle identities, there's only one option to replace sine 2x with. It is with 2 sine x cosine x. Pay attention. They're calling the angle now x, so we have to write our identity in terms of x. Over here, they had the angle theta, so we wrote our identity, we used theta. Okay, so be careful of that. So I've done my substitution. Now I know what you're going to say, well, that is not quadratic, there's no square. You're correct. But there are two different trig functions. And I want to bring this up again. If there are two different trig functions, again, you want to set this equal to 0 and factor out what they have in common. So I'm going to have to move the cosine x over here by subtracting. And here's where the mistake's going to be made. Most of you think 2 sine x cosine x minus cosine x means the cosine x's are going to cancel. That's not true. We learned in basic math you can only add and subtract things, terms that are alike. Can you subtract an x and a y? No. If I wrote this from good old algebra, if I wrote on the board 2xy minus y, could you subtract those terms? No, they're not alike. Well, the same thing here. You cannot subtract this cosine with this cosine because this term is not like this term. So we'll write them in order. 2 sine x cosine x minus cosine x equals 0. And by doing that, now you could say, well, they both have a cosine x in common. I'm going to factor that out. Because if I rewrite this as multiplication, then I can have two equations. So if I take the cosine x out of here, I'm left with 2 sine x. And if I divide negative cosine x by cosine x, I'm left with negative 1. Now I'm connected by multiplication, and now I can write my two equations. Cosine x equals 0. 2 sine x minus 1 equals 0. This one's already solved because the trig function's isolated. This linear, I got to add 1 and divide by 2. So I'll get sine x as a half. And now again, here goes our whole concept. If I'm giving you the number and I want the angle, I have to do an inverse. So I want you to write x equals. I'm going to do the cosine inverse of 0 here. And x equals, I'm going to do the sine inverse of 1/2. Well, cosine inverse of 0. 0 is very obviously coming off the unit circle. So here's our buddy, the unit circle. Where is your cosine value 0? Cosine is your x. Well, it's up here at 90, but it's also down here at 270. So we will write both because they fit in the restriction from 0 to 360. We did a minute ago, sine inverse is 1/2. Well, we know that angle's 30 degrees. And we know sine is also positive in quadrant 2, so 180 minus 30 would be 150. So this trig equation has 4 solutions. So the moral of the story is this: when you're solving a trig equation, pay close attention. If there is a double or a half angle, please make sure you can do a substitution and get it out of the equation. If you can get that angle, that double or half angle out of the equation, you're back to section 6.2 on how to solve. In our next video, we're going to find out what happens if you can't do a substitution. See you then.